Hi, welcome to another review video. This one's on how to add and subtract fractions. So when you're adding and subtracting fractions, you want to make sure that you have a common denominator. So the first thing you're going to want to do, let's say in number 3, for example here, is you want to ask yourself, what can 6ths, 7ths, and 21st all become? Well, what I like to do is ask myself, can one become the other? So we know that 7 can become 21, so we can kind of ignore the 7. So really we're just asking ourselves, what is a multiple of 6 that's also a multiple of 21? And if you think about 21, 21 times 2 is 42. So 42 is a multiple of 6 as well. So that's going to be a good common denominator. So we have 42 plus something out of 42 plus something out of 42. When you're creating your equivalent ratios, you just want to multiply by a giant 1, because when you multiply by 1, the value stays the same. So when I say giant 1, I mean basically multiplying the top and bottom of the fraction by the same value, right? And so what can I multiply 6 by to get 42? 6 times 7 is 42. I multiply the bottom by 7. I have to multiply the top by 7 as well. 1 times 7 is, in fact, 7. So 1/6 is equivalent to 7 42nds. What would I multiply 7 by to get 42? 7 times 6 is 42. I multiply the bottom by 6. I have to multiply the top by 6. 4 times 6 is 24. So 4/7 is equivalent to 24 42nds. But what I multiply 21 by to get 42? Well, 21 times 2 is 42. So then 17 times 2 would be my numerator. 17 times 2 is 34. Hence, 17 21st is the same ratio as, or equivalent ratio to, 34 42nds. Once I have them all as 42nds, then the cool thing is the bottom just stays the same. So we know the answer is going to be out of 42 42nds. That's the size of the answer, each pieces. And then we're going to just add how many pieces we have. So 7 plus 24 plus 34. So 7 plus 24 is going to be 31. 31 plus 34 is going to be 65. So you end up with 65 42nds. Let me just double check that. 20 plus 30 is 50. 8, 4 and 4 is 8. 8 and 7 is 15. So we're looking at 15 plus 50, which is 65. Yep, that works. Then we're going to ask ourselves, how many times does 42 go into 65? So we're going to simplify that. 42 goes into 65 one time. And then how many extra do you have? What's 65 take away 42? 65 take away 42, the way I like to do that is I build up from 42 to 65. So from 42 to 45 is 3. And then from 45 to 65 is 20 more. So that means there's going to be a difference of 23. So you're looking at 65 42nds is the same as 1 and 23 42nds. Ask yourself, can you simplify this ratio? And the answer is no, you cannot. So then you are done. All right, so the correct answer for number 3 is 1 and 23 42nds, and that's the process. So common denominator, add the tops, keep the bottom the same, then simplify. When you're doing number 4, it's the same exact process. What's the common denominator? 25 can become 50, so let's just use 50 then. So then we have something out of 50, take away 47 out of 50. 25 times 2 is 50. 18 times 2 is 36. So you have 36 50ths, take away 47 50ths. Now, as you guys know, taking away is the same as adding a negative. So we can think of this as 36 50ths plus negative 47 50ths. Who's going to win that battle, positive or negative? Negative. By how much? Well, what's 47 take away 36? That's going to be 11. So it's going to be negative 11 50ths as your answer. Remember, all your rules for working with positives and negatives are the same for integers, decimals, and fractions. So when you have subtraction, rewrite it as adding the opposite. And then once you have it like that, if the signs are the same, you add them up and keep the sign. If the signs are different, like in this case, you're going to find the difference and keep the sign of the larger absolute value. Okay, for number 5, you're going to look for a common denominator between 5 and 3. 5 and 3 can both become 15, so that's what we're going to use. So we have 3 and something out of 15 plus 6 and something out of 15. 5 times 3 is 15, so multiply the top by the same thing. 4 times 3 is 12. Our equivalent ratio for 4/5 is 12 15ths. 3 times 5 is 15. 1 times 5 is 5. Equivalent ratio to 1/3 is 5 15ths. You can leave it as whole in parts and deal with that as whole in parts. So 3 wholes plus 6 wholes is how many whole? 9. 12 15ths plus 5 15ths is how many 15ths? 17 15ths. Now 15 is less than 17, so we can get one more whole out of this deal. So how many times does 15 go into 17? One time. Add the 1 to the 9, you get 10. And then how many extra are left over? 2. So it's going to be 10 and 2 15ths as your final answer. For this one here, 5 and 7, what can they both become? 35. So you have 4 and something out of 35 minus 3 and something out of 35. Let's get our equivalent ratios. 5 times 7 is 35. 1 times 7 is 7. 7 times 5 is 35. 5 times 5 is 25. Here we have to ask ourselves, can I subtract straight away? Well, 7 take away 25 is not easy to do, so I have to borrow here. So actually, I'm going to rewrite this 4 and 7 35ths as 3. And then I'm going to take that whole that I borrowed and I'm cut into 35 pieces, add those 35 pieces to the top. What's 35 plus 7? 42. So I'm going to write that as 3 and 42 35ths. So 4 and 7 35ths is exactly the same value as 3 and 42 35ths. Now the advantage that gives me is now I can subtract the 42, take away the 25, I should say, from the 42. So now I can say, all right, 42 take away 25. That's going to be 25 to 30 is 5 plus another 12. So it'll be 5 plus 12, which is 17. And then you've got your denominator, which is 35, right? That's the size of the pieces. So you got 17 35ths. And what's 3 take away 3? 0. So the correct answer here is 0 and 17 35ths, dealing with the whole and the parts. And so you just can write that as 17 35ths and you are done. The key there when you're subtracting with the whole and part method is if you need to borrow to get enough pieces to take away the pieces you have over here, then just make sure you borrow. And when you borrow, all you do is when you take that whole value away from the whole, you just cut it into the number of pieces in the bottom and add those pieces to the top. Okay? All right, hopefully that helped you, and you know how to do these problems now.